Thank you so much. Hi, welcome. Glad you're all here. I'm going to apologize in advance. I don't have a lot of Lord of the Rings jokes in here aside from the title. So if you came here for that, sorry. All right. So here we're going to be talking about what stylometry is. We're going to talk about stylometric obfuscation, and we're going to take a look at the Scikit-learn Python library. Who here in this room knows what stylometry is already? Okay. Who's used Scikit-learn? Okay, about half. Okay, cool. So hopefully you will be walking away from here knowing a little something about both those things. Just a little bit about me so you know where I'm coming from. I am actually a librarian at John Jay College of Criminal Justice, which is one of the CUNY campuses. But I also have a master's degree in computational linguistics from the CUNY Graduate Center. And my thesis project for that compling degree has become an ongoing research project, which is what we'll be talking about today. That project is actually my first somewhat large Python project, large for me. And this is also my first time at PyGotham. So I'm going to call myself an aspirationally intermediate programmer level, just enough to make something cool and be proud to show it to you, but not enough that I'm not a little bit embarrassed about it too. Okay, so I'm going to talk about stylometry, but first let's go back in time to 55 years ago when the most famous stylometry paper was written. This is 1963. So this is Mosteller and Wallace's Bayesian analysis of the Federalist Papers, famous study. So as you might know from history class or from the Broadway musical, the Federalist Papers were penned anonymously under a pen name by Hamilton, Madison, and John Jay. And for most of those papers, it's pretty clear to historians who wrote what, but there are 12 papers whose authorship was in dispute. So, I have a software update from Java. Thank you. Okay. So they did a very innovative statistical analysis of the text of the Federalist Papers. So they modeled frequency distributions of the words themselves in the text. So here on this table, you see that Hamilton uses the word upon at a much higher rate than Madison does overall, looking at the papers that are known to be written by them. So just to illustrate this, here is a typical Federalist paper by Hamilton on the left and one by Madison on the right. So Hamilton is all up-ons, as Strongbed might say, and Madison tends not to use that word quite so often. It's just a different kind of a writing style, right? Hello, come on in. There's some empty seats over here. You can just come on through. So here are 4 of the 12 disputed papers, just some typical disputed papers. So visually you can see that the word upon is not used quite often, right? So that's kind of one hint that, oh, maybe Madison is the one who wrote these disputed papers and not Hamilton. So upon was only one of the 165 words that Mosteller and Wallace considered. For those who are just coming in, I'm talking about a famous stylometry study from 1963. Cool. So counterintuitively, they chose to use more common words to ascertain authorship, because it's these really common words like upon and about and necessary and thing and his, her, it that can kind of give away the author of an anonymous paper regardless of its topic, right? So more specific words like the word Congress, they're too contextual. They're not that useful for discrimination when it comes to determining authorship. Plus, we use these more common words pretty unconsciously, right? So Hamilton probably wasn't intentionally using the word upon very much. It's just the way he wrote. So in the end, the authors of the study found that there's a high likelihood that Madison wrote all 12 of the disputed papers. And importantly, just a side note, they said that their work supplements the work that historians do. It's not a replacement. So this is just one tool in your tool belt for determining authorship. And their paper laid out the statistical foundations of stylometry as we know it today. So quick definition, stylometry is the statistical measurement of an author's writing style. I realize now that quantifiable measurement is kind of an oxymoron, so let's say statistical measurement of an author's writing style or of language. Okay, so let's fast forward and see where we are at now. How can we do this kind of a study with Python? So Python is awesome for text analysis. It's quick, it's got lots of built-in libraries. So to perform the kind of stylometric analysis that we just looked at, we're going to need a couple of things. We'll need a corpus of texts, just a folder of .txt files, and a machine learning library. So I'll be focusing on Scikit-learn today. Scikit-learn was started as a Google Summer of Code project about a decade ago. And since then, it's become a very successful open source project. It's got great documentation. It's a pretty powerful library. And we're focusing on just one application of Scikit-learn today, which is classification. So a very simple classification program might distinguish between spam emails and not spam emails, right? A slightly more complex classifier might be able to distinguish which texts were written by each author in a set. So it's basing its guesses on samples it already has from these authors. So classification is basically categorization. And I'm just highlighting some like vocab terms if you are new to classification, to machine learning. So you're categorizing documents like emails and novels using a list of pre-chosen labels or tags or categories. So that would be like spam, not spam, author A, author B. And you're categorizing these documents according to some kind of features, like how often the author uses a specific set of words, like how we saw with the Federalist Papers. So you might have an anonymous novel, and you suspect that one of these 6 authors wrote it, right? Your categories in that case would be the authors. Those would be the kind of buckets that you're sorting into. So based on for example, sentence length and word frequency, your classifier could find that a novel is likely written by, say, Charlotte Bronte. Okay. Scikit-learn does have several kinds of classifiers that can take different approaches to these problems. If you're really into stats, you can dive into them on their website. We're talking about just one today. So let's run through a small example. Let's say I've got writing by these 6 authors. I'm kind of in a Halloween mode, which is why I've chosen kind of romantic Gothic authors. So I've got writing by these authors, plus I've got another document with an unknown author. So first we have to decide what should we base our classifiers decisions on. We're going to stick with word frequency, which the Federalist Papers study also used. You can also use things like word length, sentence length, punctuation frequency, emoji use, typo frequency, or some kind of like weighted combination of all of these different feature types. So for my examples today, I'm only focusing on term frequency, which is sometimes called a bag of words approach. So we'll consider like the top 1,000 most common words. Again, we're using the common words because more specific words may be much more topic focused, and we want to look at like an unconscious writing style. So we're using the super common words, 4 of which are up here. So since we're only considering some words, you'll notice that we don't care at all about word order or syntax or topics. So this is definitely like a pretty dumb approach in the grand scheme of natural language processing. But it works well enough for me, so I'm going to go with that. Quick side note before I run my sample program, just to kind of hammer this home, word frequency or term frequency, it's different than plain old word count. So since the documents we're analyzing might be of different lengths, it makes sense to use frequency rather than just counting up how often the word the is used. So we can actually compare documents to each other regardless of length. Okay, let me pull up good old idle here. So here is a oh, hang on. I've got to escape Google here. All right. Here we go. Let's minimize you. There we go. So we can read it. I'm going to pump up the font size here. What do you think, 22? Is that somewhat readable? Seeing some nods in the back. People with glasses can read it. Cool. Okay, so I'm going to kind of walk through these blocks of code here. This is just an example of how you might use Scikit-learn to perform a stylometric analysis. So first up, where's my cursor at? We're going to call in some things from Scikit-learn. We're going to call in the classifier we want to use. We're going to call in a vectorizer, which I'll revisit in a sec, and we're going to call in a way to save the classifier. So first things first, we're going to read in our data. Our data in this case are plain text files containing letters or novels or poems by some authors. This is our training data. We're going to use this data to train the classifier, which we'll then use on an anonymous document. We're going to add all of those documents to an enormous list, all right, called train docs. When we have a sister list called targets, and that's going to be the actual authors of the documents that we're reading in. So there's kind of like a matching situation with our lists. All right. From there, since we're only considering the top 1,000 words, I've already got those ready to go in a top1000.txt file. And then I'm going to define a function here called word frequency. So here's where that vectorizer comes in. So this is what takes all of those novels, letters, poems, the documents that we read in, and turns them into a giant spreadsheet like the one that we saw on the previous slide, where it's counting up the frequencies of those top 1,000 words per document. So imagine that giant spreadsheet. I know that you could probably do that with Python yourselves, but it makes it a lot easier to use Scikit-learn when they just have a ready-to-go TF IDF vectorizer. TF stands for term frequency, and I'm telling it to only consider those 1,000 words we want to use. And we don't care about inverse document frequency right now, so I'm just going to turn that one off. And it's going to return that giant array. So we're going to set up our term frequency arrays for training document sets for those documents we had before. We're going to just apply that word freak to our entire document list, and now I've got it as train TF. Cool. Next up, we're going to set up our classifier. This is the last part of this script here. I'm using a Gaussian naive Bayes classifier. Somewhat simple approach. If you're interested in other kinds of classifiers, you can check it out on Scikit-learn. So we're going to teach the classifier how to tell these authors apart, right? And this is just in this one line here. So it's going to take a look at the documents we have, take a look at the labels or the author names, and it's going to, from the term frequency array, figure out the best way to tell who wrote which documents. So it's going to come up with some predictions. It's going to figure out, and I'm going to put that in quotes because it's not a being, it's just a classifier. It's going to think of the best ways to tell apart these writing styles by term frequency, and then it's going to pop out its list of predictions. So let me run this, and I'm going to see if I can show you what happens here. All right, here we go, here we go. All right, so it's giving us a classifier accuracy on a training document set, a 1 out of 1. So we feel pretty confident about the score of the classifier. It seems like we have a pretty high confidence in being able to tell apart these authors. So now let's say that I have a anonymous text file, and I want to know which of these 6 authors wrote it. So the assumption there is that one of those 6 authors is the suspected writer, right? So let's pull this guy over here. All right, so this is just an expanded version of that script that we just saw, except I'm also going to be saving the classifier. This might be called pickling, not totally sure. I'm going to read in my anonymous.txt, or I could add other text files here as well. I'm going to do the exact same thing, set up a term frequency array. It's just going to be a 1-row array there. And then I'm going to use the classifier that I've already trained on the previous texts on a new text that has never seen before, this anonymous.txt. So let's run it, see how it goes. Okay, it's going to give us the classifier accuracy first, and then it is predicting that the author of our anonymous document is Mary Shelley. Let's pull up anonymous.txt and see whether we're right. Okay. Oh, okay. Oh no. Well, all right. Text Wrangler has quit on me. But, spoiler alert, it was Frankenstein or the Modern Prometheus, which, I don't know how to get this back on. unplug, replug, which was actually published anonymously in 1818 back in the day. However, folks back then did not need stylometry to figure out who wrote it because she dedicated it to her father, so you could kind of, follow the paper trail and figure out, oh, probably it was Mary Shelley. So this would be just one tool in your tool belt of figuring out the author of an anonymous document. So while we are figuring out how I broke the projector, I will just say that that you can see in that very small example, very small document set, small author set, how we were able to train a classifier to figure out who wrote a document that we haven't seen before. So the applications for this are quite wide-ranging, right? It's not just for people who are interested in literature like me. It's also for people in law enforcement, right? You probably saw that one coming. So on a slide which is upcoming, you will see a snippet of a report from the FBI, which classifies a writer's unique writing style as being a biometric alongside, hey, there I am again. Thank you. So again, as I was saying, thanks for bearing with me. So the FBI in this report from 2009 is calling a writer's unique writing style as a potential biometric. And this is a report, this is a recommendation for an emerging technology of authorship attribution alongside recommendations for voice recognition, handwriting recognition, face iris. And so you can kind of see how at this point, even if you're doing all the right things, if you were to write something anonymously, your own writing style could give you away, right? So just a couple of other uses of what I'm calling defensive uses of stylometry. Using writing style as a behavioral biometric identifier, the FBI is positing stylometry as a kind of a defense, as a weapon that they might use against, say, terrorist groups who recruit online or who are active in forums. So I'll just put a little side note here. If you're thinking already about things like identifying authors of ransom notes and other things that might appear in a court of law, forensic linguists have a whole different tool set that may include stylometry, but that's not what I'm focusing on today. So other research in stylometry focuses on active authorization, so that guards against fraud and hacking. So if a user's writing style deviates too far from the normal writing profile, as they're writing their emails, they're writing their Word docs, they may be flagged as a potential hacker. This lives alongside things like keystroke analysis, right? Another defensive use for stylometry is closer to home for me as an educator, which would be plagiarism software, catching students who cheat by hiring someone else to write their essay. So there's already software like Turnitin, which exists to see if a student's essay matches an existing essay. But what about someone who hires someone to write a brand new essay? So last year, a web app called Emma, which you see on the right here, which looks kind of like Eva, launched and publicized a use case for teachers where they could upload their students' papers over the course of the semester, compare them to their previous essays, and potentially flag essays whose writing profile differs substantially. You might think that like a teacher would know that already, maybe. I'm not sure how well Emma works, but they have definitely identified a use case that educators do worry about. So the previous three examples have all been about defensive uses of stylometry to catch terrorists, to prevent fraud, to find cheaters. But stylometry can also be used to uncover people who write something anonymously for less nefarious reasons. So for digital humanists, this is super exciting because we can now dig up those old poems and novels that are written anonymously and make more educated guesses about who wrote what. Okay. But it's not limited to literature. So for example, let's say you write an anonymous op-ed in the New York Times, and you may be concerned about being outed by your own writing style. I don't know who wrote that, I'm not gonna unveil that today, don't get excited. But then authors like J.K. Rowling have also been unmasked thanks to stylometry analysis. So I'm wondering, is this a privacy concern? Is there a way to outwit an authorship attribution scenario? Is there a way to use what we know about stylometry to outwit it in the future? So there are some strategies, and the first one is to write like someone else, to imitate someone else's writing style. So the study on the screen, they asked the participants to write a passage in their own voice and then to rewrite the same passage using Cormac McCarthy's voice to imitate his writing style, right, the author of The Road. And they found that this could potentially work. However, it's a lot of time and effort to imitate someone else's writing, especially if you already have something that you want to anonymize. So another strategy, which may have already occurred to some of you, is to put your writing through a translator like Google Translate and back. So that way you don't have to rewrite your entire message that you want to anonymize. You can just run it through Machine and back. So the idea is that the Translate app will keep your general meaning, but use its own dictionary to choose different words to kind of outwit that term frequency analysis that we saw before. So it may work, but there's a couple of downsides. One is that it might not be sustainable since machine translation is improving so much that your style may actually be retained. And I know that's possible now, but maybe in the near future. And on the other hand, we've all had the experience of using Google Translate and getting complete nonsense back, like on the screen, right? It actually is changing the meaning critically, so it may be a risky move. A third strategy, the last one I'll be talking about, is stylometric obfuscation. So the goal is to confuse authorship attribution software by using its own methods against it. So you might consider typical stylometry features like word frequency or sentence length and so on. Use stylometry software to identify these in your own writing, and then once you know those stylistic markers, lessen their frequency in your own writing. So starting from scratch, you know the things to avoid when you're writing, or you may be revising a message and taking out those markers that you found. And then you can also test your revised message in an authorship attribution scenario. So you can throw it into a bucket with some other writing and then figure out, oh, okay, well, it definitely is still pegging me as the author, or it's getting confused sometimes when I do this the simulation over and over again. So the goal here is to have no distinctive style, to write blandly, to write unlike yourself, but to write in a way that is to confuse an authorship attribution program. So how much time do I have left? 2 minutes, 2 minutes before questions, or 2 minutes total? Okay. So real fast, I am going to demonstrate a web app that I wrote. Let's see, is this going to work here? Let me make this skinnier. This is the project that I've been working on. It's a little bit small and scrappy, but I think it demonstrates this kind of stylometric obfuscation process. So first you need to paste in a writing sample. This is like a 7,000 plus word bit of writing. Let's see where we are here. We've got the sample here that we're going to compare your anonymous message to. So you need to have some kind of baseline to compare your new message to, right? So paste in my sample. I'm going to paste in my message here. All right, so sample is quite long. Message is a bit shorter. And I'm going to submit it. Now it's going to be comparing these two pieces of text to three other writers that you don't see. It's a background corpus, so the user is not going to be able to see what the writing is being compared to, but it's still something on the back end. And the idea here is to use nondescript, this project, this web app, recursively, so you can test again and again whether your writing is still attributed to you by this classifier the way that it is here, or whether you can confuse it. So I built in just a couple of interesting things. Okay, I know it's super tiny and you can't read it. Let me see if I can blow it up. All right, there we go, breaking my floats. Okay, so first is a very simple analysis of comparing your writing sample and your message. So here I'm looking at word length, sentence length, word similarity. That's pretty highly similar. Here I'm analyzing my overall style compared to everyone else that I've compared to, this background corpus. And then here is where you might try again. So you already know it's being attributed to you. Here's where you can revise your message. So I am taking the tack of synonym replacement. Thank you. Where I've underlined words that my system has identified as having synonyms using the Natural Language Toolkit. So when I click on rejoice, I've got some suggestions over here. So instead of rejoice, I might say triumph. Instead of assure, I might replace that with tell my dear sister. Well, okay. Instead of icy climbs, I'm going to say Arctic. Instead of it ever presents, I'm going to say always presents. Now, there are some downsides to using automatic synonym replacement because it's lacking in context. So this disk part here, it's talking about the sun and definitely not about a phonograph recording. So maybe I'm going to ignore that one. Let's scroll down here. Let's see, what else what are some of these common words that we can replace? So maybe instead of history, we'll say a story. Maybe instead of thoughts, we'll say cerebration. That's a cool word. Okay, so you can see how I'm sort of running through this, replacing words so that I may be able to outwit that term frequency analysis. I could also just do this automatically for all those underlined words and this I'm feeling fortuitous tab here, where it has just chosen some of those synonyms for me. But here it gets a little bit wonky, you know? Like I noticed when I'm scrolling down here, somewhere it replaced the word ice with nose candy. It's pretty inappropriate. That's definitely not what this author, Mary Shelley, is trying to communicate here. Or I can manually change my message here. So let's resubmit and see. I'm betting we didn't outwit the classifier here. At this point, you may be thinking it's kind of funny that I've chosen this classifier and I'm trying to outwit it, and that's a legit concern. But I'm using like a pretty simple implementation of a classifier. So this is just one tool in your privacy tool belt to try to write something anonymously. Okay, I'm seeing that I have 2 minutes left. No, I'm seeing that I have 0 minutes left. 0 minutes left. All right. I just want to point out there are some things that I have used to build this. Just a real quick recap, I use Scikit-learn, the machine learning library. I also use the Natural Language Toolkit, or NLTK, for that synonym replacement. And I also used Google while making this project. So anytime that I felt like I was a real badass Pythonista, I could go back to this list of things at Google and remember, oh yeah, there was that one time I had to Google how to find an average using Python. Okay. So some quick conclusions. I'll leave it on the board because I know we need to get to the next talk. But thank you so much. If you have more questions, you can ask me afterwards.